Hello, everyone. We're just about to start in 5 minutes. In the meanwhile, I'm going to put some music. Hello, everyone. Thanks for joining us. Good night, good evening, depending where you are. We're about to start this interesting subject about health tech 3.0, a paradigm shift. Today is here with us Omar Samdan, co-founder of InMind Software, and Josh Kindle. I don't know who want to start about this subject.
Oh, I can start. I can start. I think it's good morning for Josh, right, Josh?
Yes. Yep.
Well, that's the good thing about remote and technology in general. We can be anywhere in the world and we can still collaborate and speak and participate on this kind of interaction. So this is great. Well, further thing, Josh, thank you very much for joining. This is a series of uh, well, I'm not sure if calling it podcast, but kind of webinar where we like to discuss on different topics in a very free and open way. Discussing about technology, discussing about what is happening. Like how technology in general is changing the way we do things, the way at a personal level, at a business level, in every sense. Of course, we love to get deep into some of the main topics right now. Like what is happening on blockchain, what is happening on AI. And I thought it was interesting also to bring the health tech topic because I believe that it somehow it's joining, it's kind of a real use case that is taking advantage and will take even way more advantage of the technologies we are speaking about. So for me, this is like I would love you to present yourself and tell something about you. I will not present myself. Gabby already did it for me, so that's more than enough.
Yeah, definitely. Yeah, and first of all, yeah, thanks for having me. Hey, Gabby. Hey, Omar. Happy to be
Hey,
here.
thanks
Yeah.
for joining.
Yeah. So yeah, first of all, I'll just piggyback on what you said right at the end before I kind of introduce myself to dive right into it. Because yeah, I think that you're right that health tech is actually a great place where like AI and blockchain technology can intersect to be an actual use case. I think where blockchain is very relevant. But yeah, we can dive into that. So hey, yeah, I'm Josh Quintel. For everyone who doesn't know me, I have you maybe saw my title on the title card, working at Infura, but I actually am not here like representing Infura or anything like that. I have just been kind of researching and going down the rabbit hole of health tech and how it intersects with these technologies for like the past year. Um, but we'll get more into that. My blockchain experience is very deep though. So I've been working in developer tools in the space for many years, since really nearly the launch of Ethereum. Started out on the truffle team. Actually, originally got hired there because I made truffle boxes, which were like a series of boilerplates to get started with them. And that was how I got hired there. And then from there, it's been quite a ride. Working at Truffle, working at Near Protocol, doing developer tooling for their chain. That was very interesting because it was very Rust centric compared to like Solidity and more like JavaScript heavy type workloads on Ethereum. And then, yeah, eventually kind of made it more toward the infrastructure side with Infura. But yeah, like I was saying though, so for the last year though, relevant to our topic today, I've been researching really this health tech topic, and really it started out talking to a couple different types of researchers, really. So I talked mainly to three different types so far. So academic researchers, medical device researchers, and pharmaceutical researchers, and kind of thinking about it from this sort of dev tools centric like mindset. I immediately wanted to dive in and see like what was their development workflow, right? Like how do they take that research and actually turn that into like a trained algorithm that they then apply like in the medical field, right? Like I said, whether it's a device, whether it's in patient care, or whether it's in like developing pharmaceutical products. um, and so there were, of course, like striking similarities to any other, I think, development life cycle. Um, But a big part of especially dealing with AI and dealing with healthcare is the data, right? And there's a number of issues around that, and that's really kind of where all of it starts. A lot of it's very fragmented, especially in the U.S. I know where we don't have like a universal healthcare system of any kind. The data is extremely fragmented. It can be very difficult to use, especially because of privacy concerns, right? Either you are getting approvals from a number of individual hospitals, sometimes individual patients. Um, and so there's a lot of additional complexity there. There's actually maybe an interesting note to explore later. There's an entirely new class of insurance actually that was created when like certain additional regulation was passed around the ACA and like privacy of patient healthcare data. But either way, getting all that data, and that's even just to get to like step zero of a traditional machine learning workflow where you just have a data set that you then need to cleanse, to label. By cleanse, I mean things like deduplicating, checking for inaccuracies, things of that nature. So it really all starts there. And then from there, of course, we have like now that we actually have the data we want, we're now working on developing and training a model on that particular data. Uh, then, of course, we have actually like now we have the trained model. Now it's time to actually deploy this, and that model is going to now make new inferences about, like I said, patients, drugs, medical device information. And then from there, of course, we want to then like retrain that model. And so especially and I'll say that I'm coming from like a very again, like a very US centric view. So there's like whenever I talk about like regulation or any piece like that, I'm very much just like talking about the United States. I think in most cases it's probably a little bit easier in other places globally just because of the way the system is set up. Um, but that I guess brings me to just because it's such an overarching thing, and then we can dive in maybe to the individual pieces. A place where I think a blockchain is definitely very useful is like the chain of custody around that data, the patient data, how it's managed, how it's used by the algorithm, and then kind of enabling regulators to have a more transparent view of the entire process. Um, because again, in the United States, for example, there is this issue where even if you go through all the steps as they exist today, you get a
Mm,
trained model out there, you
mm,
then need to get regulatory approval just to update that model, right? Like I kind
mm,
of jokingly say, like Netflix's recommendation algorithm, right, updates more quickly than an algorithm that's potentially saving someone's life, right, or like contributing to that. It's kind of wild.
mm. You were mentioning about data, and their privacy is really really important. I don't know if you can talk to us about it.
Yeah, for sure. It's yeah, it's an especially difficult problem
Mm,
in health tech
mm,
because a lot of times with current privacy preserving technologies, you often have to make trade-offs between privacy and accuracy.
mm,
And in healthcare, we don't have as much as much leeway to have any margin of error there, right? So like training an algorithm and having it only be like 98% accurate, right? I mean, that 2% could be like hundreds of thousands of lives potentially, like
mm,
if we're talking about like accurately training a healthcare algorithm.
mm,
Um, and so I think that's like historically been why it's been very difficult to train models um, privately with a sufficient level of accuracy to
mm,
work in the medical field. But one of the things I've been exploring is that actually recently that doesn't have to be the case so much anymore. There's actually um, maybe I can put a link in the chat later to like a little
sure.
write up I wrote around this. Um, but there's a particular paper. If anyone
Mm,
watching wants to dive into an academic paper, I highly recommend.
good
It's
recommendation.
just called Secure ML, and in
Good.
that paper, they demonstrate there is a way to train an algorithm to, like I would say, a sufficient level of accuracy. Like we're talking like 99.999% while maintaining
But
privacy.
one thing there, just because you're bringing up a very interesting topic, and I had this kind of discussion regarding what do we expect on from AI results. Like when we read a prediction or we ask a prediction to a model, and then we say like, well, this is, sometimes doesn't even tell me exactly the same result, for the same request. So but also that's part of how AI works, how the prediction models work. It's not deterministic. It's something that, it has a certain accuracy, but also at the same time, if you compare to the context and also what it might be replacing, and I'm, putting quotes because I don't want to make anybody to think that it's just removing somebody's work, like straightforward. But when you go, I mean, when it comes to health tech and health in general, you go to the physician, and he will bring you his best advice, right? Like, I'm putting a very simple scenario. I'm trying to simplify as much as possible, but at the end, what you have is the advice of a person based on the symptoms, like, and based on some very few amount of data, and suddenly you have something that it can brings way more uh, data for his training, way more cases, way more, a lot. And probably you can calculate how accurate it is. But for the person, you cannot calculate that easily how accurate his decision or his what he thinks you may have, or what drug needs to apply, or whatever, like, you cannot, you don't treat it the same way. So um I'm bringing this from the business side, where many times we speak about, well, the should be 100% accurate, and yeah, but right now you don't have any kind of accuracy. So it's between no accuracy at all against having, I don't know, 20%, 50% accuracy. It's better than zero. But of course, when it's about lives, and safety and health of people, we are way more sensitive. So I wonder if you thought about, maybe there are special scenarios, like, well, that accuracy is, I mean, it's seen as something positive, instead of, well, you might die, like, well, this might save your life, because we are in a context maybe that is, worst, and it's better to have something positive than nothing.
Yeah, that's true. And yeah, there's kind of two things that came to mind there. Um, the first thing, well, I'll actually mention both to make sure I don't forget them. So, first thing is that yes, I mean, like the algorithm's going to be working, especially in like a clinical setting like that, which is usually called like patient support, like where a doctor's using it to assist with diagnosis. It's doing exactly that, right? It should be like assisting. So, like, there will be a medical professional who will check, ideally to see if there's maybe some wildly incorrect result, right? So that something like that should be screened for. But then the other piece is explainability, right? So to your point, not only do we get ideally like some measure of accuracy, right, based on the training set, which, as you mentioned, like you don't get with like a human mind, other than I suppose like constant standardized testing. Um, but there's an entire field, right? Like we could have like a whole separate webinar just about this, but like about AI explainability, right? Where the AI should not only be able to, of course, like make an inference, but actually like demonstrate or explain like how it arrived at that reasoning. So like that's not necessarily verbally like an LLM like saying, "Oh, here are the steps that I took to like arrive at this conclusion." Um, but like a clear example would be something like, let's say like visual diagnosis, right? Like an algorithm that looks at like an MRI, right? And it's like trying to diagnose whether something is a cancerous tumor, whether it's benign. Um, one like simple example is that it could use like heat maps, right, to show the researcher like, okay, here's like what it was actually focusing on like in the image, and what it like based that diagnosis on, so then it makes sort of that like optimization and future retraining more reliable, and then also for everyone involved, not just regulators, in this case just more transparent, and also helps deal with like false positives, false negatives, things like that, because you kind of get that additional context around how it arrived at the decision.
Great. No, it's also, and it makes me think on how how the train model arrived to that decision, like tracing back to that and being able to prove the entire, the entire chain, to get there, like, so that's, that's also a place where it make a lot of sense, especially on a very sensitive industry and context, being able to ensure that nobody can mess up with that trace, like, well, this is the data input we had, like having the provenance of that data, having exactly the steps you did for processing that data to make it, able to train something after, and, following all that chain up to the result. So in some cases, something goes wrong, you can always trace it back and say, well, there wasn't somebody messing around with the training, just to kill somebody with the diagnosis, like, because now we have those vector of attack, right? Like, now people can take advantage of AI models, to put their own way of, kind of making some malicious answers that could, harm somebody else's decision. So yeah, we need to be, like, all over the place.
Yeah, definitely. That's a place I know, especially in the blockchain space, where there's been a ton of research being done around like provable inference of the trained models, right? Like using zero knowledge proofs, putting those proofs on chain, yeah, to actually verify that the particular algorithm that's claimed to being used, that is claimed to be being used is actually the one that's being used. And then, as you're saying, yeah, to like demonstrate, um, yeah, like demonstrate that inference, then no one's kind of done like a man in the middle attack, essentially, trying to like intercept and like give some sort of like false inference, or to, yeah, like you're saying, like insert a different model into that chain somewhere.
Yeah, absolutely, absolutely. I'm pretty sure Gabby has some question, but I'm taking advantage of having the mic open. Um, uh, when because it's when we speak about data, like, it's it's not just a single set of data. We start speaking about different inputs, like they are completely disparate. What you said about how the health tech data is managed on the US, that's kind of, it's happening in other industries, and it's a common problem to be solved, like, ensuring that all the different sources of data, and in some cases this is some ongoing discussion we had, like regarding federated learning and stuff like that, where you need somehow to ensure everybody's input, and ensuring that, that's fair, that's helpful for the train model, and it's really bringing what you need as an output for, well, the purpose of that model. um, so yeah, definitely on the security side, and ensuring yeah, that, yeah, nobody is kind of hacking that process is highly important. When it comes to the incentives, like, and on the work you have been doing, when it comes to incentives, how do you think about that, like, it's because I can think you can buy data, or you can make partnerships, or you can, bring incentive for the different, data providers, because there are so many, and especially in health tech, I can think IoT devices, I can think, even our phones, that provide health data, the health care system, and everybody has data on that could be useful. I don't know, how do you think on the incentive for that?
Yeah, that's a very interesting question. I'll say straight out of the gate, I have not thought too much about the incentive from like the data provider side beyond essentially like some sort of system of paying those data providers. Um, and then rolling that up into like an algorithm that then like this company taking the payment then uses in more of like a traditional business model. Um, to the point you're getting at, though, I think that like a blockchain or maybe token based system like there's definitely huge room there, I think, for innovation as far, especially as it gets down to like you're saying that like smaller individual scale, right? Of like streaming my Apple Watch data, right, from the health app or something of that nature. Because that's like a place for like a microtransaction, I think would be very useful. And could even lead to something more like, I guess I use the Apple Watch as an example, but maybe that's not a good one because you just would pay Apple. But thinking of maybe even like an open source like health device, right? That's even more like closely tied in to those type of like individual incentives. But when it comes to the larger data sets, I mean, this is still a huge problem, right? Like I said, a lot of times health systems, um, the algorithm, the acronyms escaping me right now. It's not electronic health records. EHR. Oh no, it is. Okay, sorry. EHR companies in the United States, especially, like just try to collect as much of this data as possible, but it doesn't usually end up in a really nice unified profile. Like it's not like perfect like it sounds. Um, and then there's of course the hurdle that like such a like one large company has all this data, and so like there's not a lot of incentive for them to necessarily provide it to anyone else. You know, certain hospital health systems have been doing this as well. Any of the larger ones that you can think of, you know, they even have like accelerator programs where like giving you access to their data is like part of that. Is part of that. So like one avenue that I had explored, at least for
Mm,
getting early data, was exploring like the idea of like using posthumous data to
mm,
build an initial data set. So there's in that way, it's typically easier to get. And also you kind of sidestep the need for individual patient approval of the use of that data, because in this case,
mm.
the patient's already deceased.
Yeah,
So it can be easier to get like an overarching or like a bulk approval essentially like on a data set.
good. I think that in the future maybe some innovator people could like invent some kind of device like a rabbit or some kind of Apple Watch that can measure all your health sign of your body. And of course, if that person accept to share those data, um, and they can connect some kind of model of AI and blockchain, there's some incentive for that person to share that data. Maybe there's something there that people can work it out.
Definitely. Yeah, from the device side, I think there's a lot of interesting and I suppose for some good reasons and some artificial hurdles, like a lot to still be explored. Or there is, it's been a while, and so I don't think this product went anywhere. But in, I don't remember what country it is. It was the Philippines, or it was somewhere where like essentially medical regulations were more relaxed. There was a group of people who were kind of hacking like blood glucose monitors to do like 24/7 monitoring of people who even don't have diabetes, and they were trying to get it to also be able to check like for um, certain other health data, not just like your blood glucose level. But the point being that it was like an easy like starting point for like having, I don't know, I don't know what you'd call it. It's not a wearable. It's like a, I don't know. It's like semi integrated into your body, I suppose. Essentially, I don't know. Like I can't think of a catchy word for it offhand, but yeah, it's something that's like constantly um, actually like taking measurements of you. In that case, like from your bloodstream. In this case. But
Very,
yeah,
very
something like that, I think.
very
Yeah,
interesting. And I think that maybe that healthcare hospitals or some clinics can like if the patient accepts, of course, there's some kind of model that yeah, healthcare sector can share information of those patients for train these models, and they can receive some kind of incentive, right? What do you think, Omar, about this?
I was caught myself into an epiphany, but not an epiphany, but more like uh, crazy crazy future that I wanted to ask Josh, but so I got distracted with that. Sorry. Um, you wanna go again with a question, and I try to answer.
Ah, no, I just was wondering about what you think about these ideas of that healthcare start sharing information about patient, and at the same time, and not only the patient receive incentives, but also these healthcare institutions.
Yeah, yeah. Well, it's quite connected on what I was thinking and writing some notes down. Um, the I think that's something that could happen. Regulations are a topic. I mean, I know from some experience we have on working on some mobile app that is tied to some device, medical device, and it has to go through FDA, like going through a long, long, long process, and then by the time it's approved, and just regular stuff, right? Like it's private use app. It's not even something that is going to be sharing data and everything. But when it comes to your point, and we start, um, even if I give access, or I approve, I give consent, for the clinic, to use my data, how can I ensure myself that the data is being used for the defined purpose, like how can I be sure 100% that it's not going somewhere else, and I don't know. Suddenly, they are sharing my glucose real time, glucose level real time. We are in an era where we have neural link in our heads, and we have the model that is being trained. And suddenly, it's not. I cannot even grab the pizza because it's my neural link is telling me don't you cannot grab that. It's over for you this week. You hit the limit. So how I know sounds like a little bit crazy, but thinking on how fast everything is going, and how much do we control or we intervene on the data sharing, on our own data sharing, like I think that's going to be a topic, because usually, like, we all wants to have access to data. We need data. It's more than ever. It's called they talk about the new oil, or stuff like that. So but that's I mean, that's real, that's happening, and it's going to be more and more and more. So we will see those incentives to be sharing our data, in a way, but how do we ensure that we are not going too far, like, that we can still take a step back on that, and ensure that, well, yeah, I wanted to provide my data, but now I don't want to share it anymore. So still being in control, when it comes to private data, health data, because, yeah, I want to be safe. Like, if I have some illness, I will do everything as possible, share everything, but at some point, I don't want to do anymore. So, how do we how yeah, that's something that somehow concerns me, and would be interesting also to know what Josh thinks about it. Like, thinking in a not so far future.
Yeah, I mean, oh man, there's a few things there. One, the Neuralink pizza thing, I definitely want to go back to. Um, but I'll kind of walk my way back there, I guess, going backwards. So recently, I finally caved and I did a 23andMe test. And for the longest time, I resisted doing it at all for like these exact concerns, right? And like my biggest one was definitely like, oh, they're gonna just sell my genetic screening to an insurance company, right? Who then is going to say, oh, you might be susceptible to this disease, so we're gonna jack up your rate, right? Um, and part of that, and I'll confess, I don't know like where the line is for this. Now, part of this is regulatory, and part of this might be them self-governing a little bit. I think it's mostly the regulatory angle. Um, but they do a very good job actually of getting like, and it is a laborious sign up process. It probably loses them a lot of signups actually, but you go through and like very granularly um, toggle essentially like what you want your healthcare data to be shared for, right? Everything from like research studies, the type of study, down to whether any like private organization can use it for anything. And again, like the class of organization, the purpose for which the organization is requesting it, things of that nature. And as far as the insurance concern, the thing that got me was they actually like very specifically outlined. And again, I think I should have looked it up just before this, but I think on this portion, it was a regulatory issue actually. So I had some like government level assurance, but um, the first thing they mention is that it is not shared with insurance companies in the very beginning. So that was my biggest concern. So I think it's some combination of that, of like us accepting that like we are gonna have to like as individuals get more involved like in those decisions, even though like maybe signing up for certain things is going to take a while. I mean, I think the whole process might have taken like an hour for me to go through it and actually read everything. Um, that combined with actual end-to-end encryption, something maybe like fully homomorphic encryption, where you're even like never giving up your data, you're just giving up like an encrypted form of it that can still like computations can be run on that encrypted version. But even let's say if someone were to access the data itself, it would just be encrypted. It would be encrypted. It wouldn't be um, in any way accessible, essentially. Um, so I think it's kind of those two portions. Now I know, like, and historically in the industry, right? Like, there probably does need to be another like regulatory step in here, or some sort of additional assurance, because like end-to-end encryption, if anyone remembers, like with Facebook Messenger versus like other messaging platforms, let's say like Signal or something, right? Like Signal, like actually end-to-end encrypted, right? Device to device end-to-end encryption. But Facebook Messenger, and I don't know if they've changed this, so forgive me, Meta, if they have. But at one time, it was revealed that even though they claimed it was end-to-end encrypted, that like Facebook servers still had the encryption keys. They weren't on your device. So like technically at any point in time,
Yeah.
Meta could decrypt your message. So like we definitely would want that more signal style end-to-end encryption. Um, but yes, now to the point of the Neuralink pizza. I mean, this goes back. This touches actually on the blockchain space again, because this is like, I think in many ways, it's after the World Economic Forum, like maybe a justified like paranoia or concern, I should say, around like something like a world coin, or like any kind of like nationally backed digital currency, right? And the concern was kind of the same thing, right? That like you'd go to spend, you know, whatever US Fed coin like from your wallet, and it would say, oh, well, no, actually, you've bought too much fast food or too much meat, or this month or this week, and it would actually like not allow you to make a purchase, right? Or in your case, even more dystopic, like with Neuralink, like you can't even like make a decision to eat something that's right in front of you. Um, I mean, I think there is always going to be sort of this bad impulse, or it always manifests as a bad impulse. Maybe it comes from a good place for some people, of like this thought of like making everyone healthy or optimizing society a certain way. But these things, they crop up like cyclically, like every now and again, especially with new technology, right? They manifest as this like extreme control of people's behavior, and it's kind of an unsatisfying answer, but like that's gonna be a multi-pronged thing. That'll be like societal will need to continue like resisting that type of control and like finding other ways to. It comes back to what we were talking about earlier: incentivize good decisions rather than
Yeah,
control people's behavior.
exactly. Totally. We were like a very futuristic right now, but now I'm wondering about where we at Health Tech 3.0. I don't know if you have seen some kind of applications that you can tell us.
Yeah, I mean, there are pieces everywhere. Yeah, let me see if I can. Let me look in this document here, actually, in
Yeah,
my
sure.
research, and
Look
give you
for
some
it.
specific people. Because yeah, no, there's been advancement in a number of places here.
Yeah, because I've been hearing that like a doctor has been starting to work along with AI for predicting some kind of diseases through an MAR images. But I don't know what else, what other
Yeah,
applications
there's
are right
that's
now.
definitely one. I'm trying to think of the name. That's why I'm searching here because I want to like name some of these startups because they're all very interesting. Um, but there is one, yes, that is definitely directly applying like
Yeah,
AI to MRI images.
I don't know if
There's
you
another
have heard
one.
Omar.
Oh,
No, I was remembering in one case. It's quite recent. It has to do with the sugar level, like measuring, but also training. Training your behavior. So it, what I've seen is a change or a switch between we have the data, we provide insights, and based on that, you figure out how to resolve it, or you have some insight based recommendation. But now we have the opportunity of using those AI models, and there are some startups around that they read the data, your
Mm,
data, and
mm,
based on the funding model, they start improving,
mm,
that, and it's providing you recommendations way more accurate,
mm,
because it's not based on a set of templates. it's
mm,
it's it's specifically for you and your behaviors, and it's learning and improving over the time. So if you start,
that's
on your breakfast, you start trying
mm,
stuff, it
mm,
it start helping you on say, well, if you start with an avocado toast,
mm,
it's your sugar level up better than
mm,
if you start, like a butter toast, or if you start with the avocado and
mm,
then 10 minutes after you take the toast, you eat the
mm,
toast, it's even better because the avocado is it's
mm.
kind of blocking the sugar level that is
Yeah.
going to be up because of the. So I know a couple of cases that they are working, and they
Mm.
are having production level application on that end.
Oh, good. Yeah, that's really interesting because I have seen like an apps where you can control what you eat when you're trying to get fit. And maybe that data that you provide to your phone to that app can serve to eat better or to get you fit or whatever objectives you have in mind. And AI, of course, can get in and provide you some kind of meal prep or recipes for the week or for the whole month.
yeah, I know the humanity AI pin now at this point, I think is kind of become like the butt of a lot of industry jokes, but like at least if they could optimize it, like, and the people said that a lot of that about blockchain technology, except these things are iterative. So like we'll probably get there, especially with their level of funding. But one of the coolest things that I thought it had potential for was their example of like, oh, how many calories are in this handful of almonds, right? And you hold that in front of it because it's like not having to pull out your phone. It was actually like a use case where I thought, oh, actually having a pin mounted camera kind of makes sense here. Like
Yeah,
probably more naturally, like I think Meta again probably going the right direction with like having it integrated into a pair of glasses or something very natural where like it's just, to your point, like it's kind of constantly analyzing what you're eating and you can just give you like recommendations very naturally
exactly.
based on that. Yeah, I always thought that was exciting too. Oh, I did find that list of companies though, so I can go through like a couple of them now. The ones like we're kind of taking notes on, we're very focused on this like private machine learning aspect, and some were more healthcare focused. Some were a little more narrowly focused. But one that I know is definitely like an industry leader, or at least has definitely been talking about this for a long period of time, is a company called Zama, like Zama, Zama.ai. And they've been focusing on using something we mentioned here, actually, fully homomorphic encryption to um, train machine learning models on private data. Because for those who don't know, I guess I'll take a step back because there's a lot of like word soup in encryption, especially. But like, so fully homomorphic encryption refers to the ability to perform a computation or like a mathematical operation on a set of data or on a piece of data, I should say, while it's encrypted. And that translates to the same result if that data were not encrypted. So basically, it allows computation on encrypted data without having to decrypt it, which is pretty awesome.
Wow.
And so, yeah, that's something I know Zama's looked at. The disadvantage, especially right now, is that it's just a lot slower
Yeah,
than other
it
methods
doesn't
and
scale.
computationally expensive.
It doesn't scale yet where we will need. In particular, I've been just in. I've been like 2 months ago. I think I was in discussions with Zama, because of the use of the fully homomorphic encryption. And yeah, the topic always there is how scalable it is. What kind of computation you can do. So you try to minimize your problem to numbers if you can, and working with that. So, but yeah, it's exciting what they are doing, and they there is still a lot of room for
Yeah.
improvement and scaling that. So.
Yeah. About what you're saying, Omar, just for closing, I don't know if each one of you wants some kind of, say, some advice for this healthcare institution that want to incorporate like these technologies into their businesses.
Please, Josh, be my guest.
Oh man, that's interesting. Advice for any healthcare institutions. Hmm. I mean, on some level, it's just the very basic advice of just being more open to some of the
Of
possibilities.
course. Yeah.
I mean, I think again, I think some of the larger like hospital systems like Mount Sinai and things like that, I know they have like incubator programs. They're like
Mhm.
actively, looking into some of these things more.
Mhm.
Um, but they're almost, and I don't know if maybe this has been tried in the past and
Mhm.
it failed for some reason, but there almost needs to be some kind of like industry working group where multiple health systems are coming together um, to work on some of this technology.
Yeah.
Because again, the biggest hurdles that I've seen have mostly not been technological, right? Like those, it's just a matter of like, okay, we need to optimize a certain
Mm.
algorithm, we need more computing power. Like there are solutions there, but it's like the actual barriers oftentimes end up being either regulatory or
Mhm.
in the case of like the industry, just various little issues of like incumbents
Mhm.
either like not even necessarily protecting the data, but just like not being willing to collaborate. Like basically the environment is not collaborative really at all. I mean, and sometimes it's purposeful, like I said, almost like protectionism, but other times there's just a basic lack of optimization. I mean, even some of the researchers I talked to, they were frustrated that even departments within the same hospital will
Mhm.
have incorrect or conflicting data about the same patient.
Wow. Yeah.
That's, I mean,
That's
we
strong.
just start there.
Wow. Yeah.
Yeah,
I don't
yeah.
know if you want to say anything else, Omar, or we're going to.
No, I think we can wrap it up. I,
Okay.
I, I do believe that a lot of these, I will aim for the, not aim is not the right word, but I will say that the protectionism is probably the biggest driver for not collaborating. I mean, it's an industry that is, you know, worth a lot, and who controls the data. It's important, but at the same time, I think it's we there are a lot of opportunity out there for once we we step up on the collaborations or the lack of collaboration, we will be able to see a lot. We will be able to see a lot. We will be able to build a lot. So yeah, and I think that's going to be, step by step, because at some point they will reach the limit. So you will need to start opening up for giving room for more innovation, for better results, for new
Yeah,
applications, new developments, and yeah. So
that's gonna happen sooner or later.
it
Thank
will,
you,
it
guys.
will.
Thank you, Josh, for joining us. See you in the next live event. Follow us in our social media. Um, See you again. Good night. Good morning. See you.
Good
Bye.
night, good day. Thank
Yeah,
you very
thanks,
much,
Gabby.
Josh.
Thanks so
It's been
much
a
for having
pleasure as
me.
always.
Yes, definitely. Same to you.